Sometimes there's more than one way to do something, and the same is true for an access control list. Up to this point in these videos, we've been taking a look at numbered access control lists for 1 through 99 for standard, and then 100 through 199 is the typical range for extended. But we also have the ability to create what's called a named access control list, and in my opinion, they're easier to manage if we do it that way. So that's what we get to talk about and demonstrate in this video in lab, is using a named access control list. So let's imagine that we've been asked to implement this type of access control with an extended access control list and to do it inbound on R1. So as we take a look at this plan, what we're going to do is we're going to use a named access list as opposed to using a number like 100 through 199. So before we go to the configuration mode, we have 3 steps, and that is to design or plan, and then create the list, and then go ahead and apply it. And we're going to apply it inbound on gig 00. So before we can create the list, let's take a look at our plan. They want us to deny TCP traffic from PC10's address, which is 10.16.0.10, going anywhere to any destination IP address if the TCP port is 21. Okay, so 21 is the well-known port for FTP. So that basically means that past this point in the router, this PC gets no FTP access. Entry number 2, they wanted to go ahead and deny IP traffic if it's sourced from VLAN 10, which would be 10.16.0 with a 24-bit mask, and then the wildcard mask would be 0.0.0.255. So we can do that, and the destination is Florida. Now Florida down here, so Florida has a few subnets down here, but their address space is 10.16.16.0/21. So if we want to match on anything with that destination, we need to use that network, 10.16.16.0, with the appropriate wildcard mask that represents the 21-bit network, which would be 0.0. And then we'd break in the third octet, and it would work out to be 7.255. And we've stepped through the logic and math for that based on this network previously in these videos. So for the Florida destination, we'll go ahead and include this as the line for the destination for denying traffic. And I'm not sure what this VLAN did up here, VLAN 10, but they are not going to get access to this network down here in Florida once those packets show up at gig 00, once we implement this. All right, that's line 1 and line 2. Line 3 says we're going to deny ICMP traffic sourced from VLAN 10, which is this network right here, if it's destined for VLAN 20. Okay, so VLAN 20 is 10.16.2.0/24. So we can use the appropriate wildcard mask for that, which would be 0.0.0.255. Great. And then this last entry is regarding IP, IPv4, permitting everything else that wasn't matched on the prior 3 lines. So in implementing this, and I encourage you to do this in the lab with me, by implementing this, we're going to have an opportunity to see a named access control list, and as I'm looking at the task here, several entries in our access control list that will give us practice in working with an extended ACL. So let's go to the command line interface on R1 and get to work. And to make sure we do this right, I actually went and printed out that screenshot I just made so I could make sure I had the information in front of me while I configure it. And one of the things that we'll discover is that there are so many commands in the world of the Cisco iOS and devices that using the context-sensitive help and the question mark is going to become a common thing just to verify where you are in the syntax. So let's go to the hands-on lab and let's apply this access control list. So here we are on our management computer. I've launched PuTTY and I've opened up a console to router 1. And as always, we're going to verify what we have in the way of access list before we start configuring. So show access list, press enter. Great, no access list, let's begin. So to create a named extended access list, the command we're going to use is IP access list extended, and then we give it a name. So let's go ahead and call this our ACL, just like that. Boom. And that puts us into access list configuration mode. And now we can just put in the permits and deny statements right here, one after the other. And for me, this is a more comfortable and easy way to put in multiple access control list statements. So our first statement is going to be a deny. So we'll say deny space, and then we'll use our question mark. What do we want to deny? We want to deny TCP at layer 4, and we use a question mark. And then it's asking us about the source address. And because it's just PC10, I'm going to use the keyword of host and follow it by the IP address of PC10, which is 10.16.0.10. Or we could have put in that IP address followed by a wildcard mask of all zeros. That would mean the same thing. Then we'll do a space. Then we'll do a question mark. And now we can identify the destination. We also have options for regarding the source TCP port. If we were concerned about that, we could add that here as well. In our case, we don't care about the source TCP port. We just are looking for the destination port of 21, going anywhere. So for the destination of anywhere, we'll say any, space, a question mark. And then what we want to do is this one right here, the EQ for equals. And so we'll hit a character to stop the paging, type in EQ space, and then we'll specify the port of 21 and press enter. So this entry in this access control list says I'm going to deny TCP traffic if it's sourced from the host at 10.16.0.10 and it's going anywhere and the destination port is TCP port 21. So let's take a look at our task list. So that's our first entry. Next, we want to deny all IP traffic from VLAN 10 going to Florida. All right, let's do it. So it's going to be deny space. And then for what we're going to deny, it's the entire IPv4 protocol suite. So we're going to type in IP space, question mark, and the source is VLAN 10. So in our network, that VLAN 10 is 10.16.0.0 with a 24-bit mask. So the wildcard would say we want to match on the first octet, the second octet, the third octet, and I don't care about the fourth octet, just like that for the wildcard mask. And next, we can put in the destination, which is going to be Florida. So Florida's address space is 10.16.16.0 with a 21-bit mask. And as we discussed earlier, the wildcard for that would be 0.0, meaning we care about matching the first 2 octets, and we only care about matching the first 5 bits of that third octet, which a wildcard mask for that would be .7, and then we don't care about the last octet at all. And then a space and a question mark. And let's take a look. Deny IP traffic from the 10.16.0 network if it's destined for the 10.16.16 network, and that looks good, and we can just press enter, and now we have 2 lines in our access control list. Let's take a look at the third. For the third line, we want to deny ICMP traffic sourced from VLAN 10 if it's going to VLAN 20, and VLAN 20 is the network 10.16.2.0 with a 24-bit mask. So back at the CLI in our access list configuration mode, we're going to type in deny space ICMP and then the subnet 10.16.0.0. We care about matching on the first 3 octets. Great. And the destination, if you ever need help, just do a question mark. It'll show you where you're at. And for the destination, it is VLAN 20, which is 10.16.2.0 with a 24-bit mask. And so the wildcard would be the inverted mask of 0.0.0.255 and press enter. Fantastic. So we can do a do show access list. See what we have so far. So we have our 3 entries, so far so good, and now we need to add the final permit to permit everything else that wasn't previously matched. So to do that, we'll do permit space and then IP any for the source, any for the destination, enter. So now that our access list has been designed and created, our third step is to apply it to that gig 00 interface on router 1. So to do that, we'll go into interface configuration mode for gig 0/0. We'll do the command IP access group. I'm just going to copy paste that here. And then we'll specify the direction. In our case, we want it to compare that access control list to any incoming packets that are trying to come into that interface from the network. So we'll use the keyword of in and press enter. And then we'll verify that with a show IP interface for gig 0/0 and press enter. And here in the output for show IP interface gig 00, it's showing us that our inbound access control list is our ACL, the one we just created and applied. So now to test this, let's go back to our client. So here on the client PC in the lab, and let me go ahead and clear off that screen. If this client tries to use FTP, which uses the destination TCP well-known port of 21, this client should not make it any further than router 1, which is going to deny that traffic. So we could do this as a test. We could do FTP space and the IP address of 192.168.1.100, press enter, and you see how it's kind of like hanging there? That's because R1 is just killing all those initial packets based on TCP traffic coming from this source IP address with a well-known destination port of 21. It's just killing it. So it's just going to hang here. It's not going to fly. If we take off the access list and we try it again, we would then get a connection request and the FTP server would be asking us to log in. So the FTP timed out, and that's great news, but we're not just going to assume, oh, the access list must have worked. We're also going to go back to the access list and look at the hit counters to verify that there's matches on that specific line of the ACL. So I'm going to go ahead and type in BYE to get out of the FTP prompt. The next one is the trying to reach Florida. So we tried to ping out to a Florida address. Let me give you one. This ping to 10 16.16 dot who's out there? 222 is out there, but it won't matter too much because once that packet gets received on gig 00, R1's going to say, killing it. So we'll try it, but there we have a response from R1, who owns that .5 address, saying, yep, killed your packet, killed your packet, killed your packet, access control list is in place, sorry. Actually, I don't even think it says sorry. It's just saying I killed your packet. So next, let's go ahead and try a ping, which is going to use ICMP from VLAN 10 over to a device in VLAN 20. And to do that, let's do a ping to 10.16. Who do I have out there? 10.16.2. Let's go to .2. Now, that's an IP address of the interface VLAN 20 on core 2. So let's see if we can ping that. Oh my gosh, wait a sec, I gotta chat. And oh my gosh, I am so leaving this in because this is classic. We created an access control list entry that said, deny ICMP traffic going from VLAN 10 to VLAN 20. We did, I saw it, we did it, and we applied it. However, the traffic going between VLAN 10 and VLAN 20 doesn't go through R1. It's our multi-layer switch core 1 that's doing that routing. And there's no access control list on it at the moment. So what I'll do is I will bake in to our case study where we apply our skills to the production network. I will bake in access control list using our multi-layer switches to control that traffic between VLAN 10 and VLAN 20. So this is a great example of verifying what we do to make sure that we get the results. In this case, the access control list on router 1 isn't going to have an effect between VLAN 10 and VLAN 20 because router 1 isn't the router between those two networks. And we can verify that too if we do a TRACERT space -D and then go to 10.16.2.2, press enter. Yeah, our first hop is the multi-layer switch core 1 at 10.6.0.1, and then the second hop is core 2's VLAN 20 interface who's responding back to us. And then for our last statement, it was permit any. So let's go back to our management computer, DCNUG. We'll go back to the command line interface, and let's do a show access lists just to take a look at the matches. Yep, sure enough. So for the FTP, we had some denies, great. So the PC was not getting FTP services. For the denying IP between 10.16.0 and 10.16.16, which is out in Florida, that got denied, fantastic. And look at this. This entry right here has no matches, and that's because router 1 is not involved in the routing directly between VLAN 10 and VLAN 20. So there's no matches on that line. And then for everything else, all the other traffic that didn't match these prior lines, this last line picked them all up with a permit, IP, everything else. So I've had a great time in this lab in implementing a named extended access control list and then verifying the results of that work. So I hope you do that in the hands-on lab as well. So for the next video, here's what we get to do. We have a new set of requirements that we've been asked to implement on the production network, including applying the access control list to some switched virtual interfaces on the multi-layer switch, and we're going to tackle that head on in the very next video. So we'll see you there in just a moment. Meanwhile, I hope this has been informative for you, and I would like to thank you for viewing.